Okay, so the next concept that we want to discuss is power. And we're going to abbreviate power with a cursive P. So you might be wondering, well, why don't I use a regular P for power? That's because I like to use the regular P for pressure. And we're not really going to be doing a whole lot with pressure in this course, but I just like to use one letter to represent different concepts in physics. So I'm going to use a cursive P for power, and the definition of power is it's going to be the rate at which you use energy, or it could be the rate at which you generate energy. So let's take a look at this formula here, and it says that power is going to be the amount of energy that you use, or it could be the amount of energy that is being generated in a certain amount of time. So T for time. So let's look at the units for this. We know that the official metric unit for energy is going to be the joule, and we know that the official metric unit for time is going to be the second. So we could say that the official metric unit for power is going to be a joule per second, but in the metric system we have a special name for this, and we're going to call it the watt. So capital W for watts. And so you might be familiar with that concept, because if you go to a store and let's say that you buy a light bulb, okay, a typical wattage for a light bulb is, let's say, 100 watts. So what's the difference between buying a 100 watt light bulb and getting a, let's say, a 40 watt light bulb? Okay, the 100 watt light bulb is going to be brighter, but you can't get something for nothing. So if it's brighter, then that means it uses more energy. So a 100 watt light bulb is going to use 100 joules of energy every second. If you get the 40 watt light bulb, well, the good news is it's not going to use as much energy. So the 40 watt is going to use 40 joules of energy every second. But it's the good news is, or the bad news is, it's going to be dimmer. So that shows you the difference in wattages and what it means. Now you could have something that uses a tremendous amount of energy. Okay, so let's say that it's using a huge amount of energy. So I'm going to draw a large E. Okay, but if it uses that energy over a long period of time, well, then if you divide by a big number, it doesn't matter that this number appears big. If you divide by a bigger number, then what happens is the amount of power that that particular device uses is very, very small. Okay, but if you've got this huge amount of energy that this device produces, and it does it in a very short period of time, then if you divide by a small number, then what comes out is going to be a big number. So just remember that power is a combination of energy, and you also have to take into account time when you do that. So let's look at an example here. You have a 3 kilowatt generator, and it's going to run for 30 minutes. How much energy did it use? Okay, so we're going to write down what we're given and what we're looking for. So when you see the word watt, even if it's got the K in front of it, kilowatts, remember that that's a unit of power. So we know that P is equal to the 3 kilowatts. But that's the wrong units. We need to get rid of the word kilo. So you should know that a kilometer, a kilometer, is 1,000 meters. So a kilowatt must be 3,000, or must be 1,000 watts. So 3 kilowatts must be 3,000 watts. And then it says 30 minutes, so that's time, T, but it's in the wrong units. We need to convert it to official metric units, which is going to be seconds. So 30 minutes, multiply that by 60 seconds, gives you 1,800 seconds. And then it's asking how much energy did it use, so we're looking for the letter E. So we're going to plug it into this formula here and then do some algebra on it, and then it turns out to be 5,400,000. And now we need to tack on what's the official metric unit for energy, and it would be the joule. Now, if you had wanted to, though, you could have said for your answer that it was 5,400,000, and then you could have said that it was a watt second, and that would have been perfectly okay on the exam, because a watt second is the same thing as a joule. So all of these metric units, they fit together, and that's one of the reasons why we like the metric system. So that's the concept of power. So here are some typical powers, in case you're wondering. So the United States, for example, uses 2 times 10 to the 12th joules per second. So that's the energy per second that the United States uses, and so that would be in watts, joules per second. All right, let's take a break. When we come back, we're going to talk about what a simple machine is.